Hey guys, welcome back. In this class, we're going to solve question 3 from SSC November 2003. So the question says, a point X is on a bearing of 65 degrees and at a distance of 57 meters from a point Y. Another point Z is 84 meters from X and on a bearing of 145 degrees from Y. So we have to find the bearing of Z from X, correct to the nearest degree. Then B, we have to find the distance of Z from Y, correct to 3 significant figure. So now let's solve this question. So this question is slightly different from the others. So here we have to interpret this question into a diagrammic form. So we have 3 points. We have point X, and we have a point Y, and we have a point Z. Okay. And we are told that X is on a bearing of 65 degrees and at a distance of 57 meters. So Y connects to X at 65 degrees, 065 degrees, and Y connects to Z on a bearing at 145 degrees. So it means that from this side to here is 145 degrees. So if we take 145 from 65 degrees, we have 14 minus 6 is 80 degrees. So it implies that this side from here to here is 80 degrees. Now let's complete our diagram. I'll connect from Z to X. So we know the distance from Y to X to be 57 meters. And we equally know the distance from Z to X to be 84 meters. So we don't know this angle. Let's call it theta. And let's call this angle alpha. So we have this small angle here to be 65 degrees. Since 65 degrees here is alternate to this angle. So if we add 180 degrees plus 65 degrees, we get 245 degrees. So altogether we have this angle to be 245 degrees. So to find the bearing of Z from X, from our diagram, we are looking for the angle from this side to this side. So we are asked to find the angle from this side to this side. And we know the whole angle to be 245 degrees. So in order to find the angle from this side to this side, we simply subtract 245 degrees from theta. Also, we know our theta to be equal to 180 minus 80 plus alpha. This is the sum of angle in a triangle. So now, using sine rule to solve the problem, we have here to be small z, and we have here to be small y, and we have here to be small x. We have our sine root to be b over sine b is equal to c over sine c. So in this question, our parameters are quite different. So our b here will be y over sine y is equal to small z over sine z. Let's look at the question. Our y here is 84 meters, our z here is 57 meters. So we have our y to be 84 meters over sine y is equal to 57 meter over sine z. So let's check for the angle of y. The angle of y is 80, so we have here to be 84 meters over sine 80 degrees is equal to 57 meters over sine alpha. So to find alpha, we cross multiply. We have 84 meters sine alpha is equal to 57 meters sine 80 degrees. So we have sine alpha is equal to, divide both sides by 84. We have 57 meters sine 80 degrees over 84. So have our sine alpha to be equal to 0.6683. So alpha is equal to the sine inverse of 0.6683. Our alpha will give us 41.93. Once you use your calculator, this is what you get. Finally, our alpha will give us 42 degrees. We've gotten our alpha to be 42 degrees. Now we'll find theta. So our theta is 180 degrees minus 80 plus alpha. So our theta is equal to 180 degrees minus 80 plus 42 degrees. So our theta is equal to 180 minus 122 degrees. So our theta is equal to 58 degrees. So since we have succeeded in finding theta, we remember that the bearing of z from x is equal to 245 degrees minus theta. Since you know our theta now to be 58 degrees, so the bearing of z from x is equal to 245 degrees minus 58 degrees. So our final answer is 187 degrees. So this is the bearing of z from x. Now we are not done yet. This is the first part. To solve the second part, so we've gotten alpha to be 42 degrees and we've gotten our theta to be 58 degrees. And now we know the bearing from this point to this point to be 187 degrees. Now we've succeeded in finding the bearing of z from x. Now we have to find the distance of z from y, correct to 3 significant figure. Now let's solve this question. So at this point we are going to use cosine rule to solve this question. And we know our cosine rule to be b square is equal to a square plus c square minus 2ac cos b. So in this case, our formula will be a little bit different. Since we are looking for this distance, x distance, which is unknown, so we are looking for x distance is going to be x square is equal to y square plus z square minus 2yz cos theta. So I have x square is equal to 84 square plus 57 square minus 2 into bracket 84 times 57 cos 58 degrees. So I have our x squared to be equal to 7056 plus 3249 minus 2 into bracket 4788 multiplied by cos 58 degrees is 0.5299. So have our x squared to be equal to 10,305, 5,000 and 74.3. So how are x squared to be equal to 5230.7? When you use your calculator, please use your calculator to cross-check. X is equal to the root of 5230.7. So have x to be equal to 72.323. Now we're asked to leave our answer in 3 significant figures. So the distance of z from y correct to 3 significant figure is x is equal to 72.3 kilometer, and this is our final answer. Thank you for watching this video. On our next video, we'll solve question 4 on bearing and distance. Take care.